Welcome to EC Elimu Learning Simplified, and welcome to this lesson. In the previous lesson, we discussed how to draw ray diagrams on either convex mirror or concave mirror, but that was just an approximation because we were not interested with the height of the image that was formed or height of the object that we used. But now, if we are interested in the height of the image that will be formed, then we must place an object whose height we know. Then we are going to construct the ray diagrams for that. But in this case, it's done using a graph paper for accuracy purposes. So that's what we're going to discuss in this lesson, graphical construction of ray diagrams. My name is Albert. I hope you will enjoy the lesson. By the end of this lesson, I expect you to be able to accurately construct ray diagrams on a graph paper, and then later we will discuss few examples in which we are going to construct ray diagrams on a graph paper. Then we are going to use it to determine the characteristics of the image formed, the height of the image formed, the distance of the image from the mirror, and even the distance of the object from the mirror. So images obtained from curved mirrors can be drawn to scale in a ray diagram. Drawing to scale means you can compress your scale such that it can fit the graph that you have. Like in this case, if you have an object of height 20 meter, you cannot draw 20 meter on this small graph. What you do, you can use a scale like 1 centimeter represent 10 meter. So in this case, we are only going to use 2 centimeters to represent 20 meter. That is a vertical because images are always vertical. Then for horizontal scale, this is a vertical scale. For horizontal scale, let's say you have a mirror which has this height, which has a focal length of 30 centimeter. You cannot draw 30 centimeters on this small graph. So here you can even say of our horizontal scale, 1 centimeter represent 15 represent 15 centimeter. So in this case, you're only going to need 2 centimeters to represent a focal length of 30. So in this case, you can determine a vertical scale differently. This is a vertical, this is vertical, then horizontal scale. You can determine them separately, but they should be uniform. Horizontal should be uniform, vertical should be uniform. Then another thing that you need to know is that for accuracy purposes, we draw these graphs, all these diagrams on a graph paper. And before you draw them on a graph paper, then you have to draw a representation of this mirror that you are using on this graph. Like if you have a concave mirror, we're going to begin with a concave mirror. We have drawn several representations. Then you have to draw a vertical line which will represent the mirror that you are using. Then you have to draw a horizontal line which will represent the principal axis. So horizontal line here will represent the principal axis. And then this one is a mirror. In this case, the concave mirror. The reflecting surface is facing outside, or it is bending inside. So in this case, then you have to determine the focal length. Like in this case, if you have 2 centimeters as a focal length, then this will be the focal point. Another 2 centimeters from the focal point, that is 4 centimeters from the pole, will represent the center of curvature. And now if you place an object here of any height, then you can construct it on that diagram. Then for a concave or convex mirror, we can now consider a diagram, a representation of a convex mirror or convex. Then you have to draw a horizontal line which will represent the principal axis. This is the principal axis. In this case, this is the axis. Then you have to draw a vertical line which will represent the mirror itself. In this case, we draw like that. This is our mirror. Then in this case, the reflecting surface bends outside. Then we can now determine the position of the focal length. Remember, focal length for all the focal point of a convex mirror is behind the mirror. So if it's 2 centimeters, it will be here. This is the focal point. Then therefore, the center of curvature will be here, C. Then if now you can place any object in front of this mirror, you can be able to construct it diagrammatically or graphically. And then you can measure using your ruler the length and the width or the height of the image or the distance of this object or the image from the mirror. So we can now handle a few questions here so that we understand better. So in this case, the first question reads, a concave mirror of focal length 10 centimeter forms a real image of height 5 centimeter at a distance 20 centimeter in front of a mirror. Find by scale drawing the position and the size of the object. So here what we do, we have to identify what we have first. We have the focal length, which is 10 centimeter. Then we have the distance of the image to the mirror or to the pole, which is in this case V, which is 20 centimeter. Then we have a height of the image. The height of the image which is formed is 5 centimeter. Then now they are asking us to find by scale drawing the position and the size of the object. So in this case, they want us to find the size of the object, that is HO. So in this case, what we have to do is to identify what will lie on the horizontal scale and what will lie on the vertical scale. So in this case, the focal length and the distance from the mirror will lie on the horizontal scale. And then these two, the height of the image and the height of the object, will lie on the vertical scale. Now we will use these figures that we have here to determine the scale that we will use on horizontal scale. Like in horizontal scale, we have the maximum distance as 20 centimeter and minimum as 10. So here we can use a scale like 1 centimeter on horizontal scale will represent 5 centimeter. Then now on a vertical scale, we have the maximum as 5, and then we don't know the height of the object. So in this case, we can use like 1 centimeter represent 2.5 centimeter on a vertical scale. Then after this, what we'll do is to draw the representation of this mirror on this graph. So this is a concave mirror. So for a concave mirror, we have to draw a horizontal line which will represent the principal axis. So this is the principal axis. Then we have to draw a vertical line which will represent the mirror that we are using. So this one here is the mirror that we are using, and it's a concave mirror since the reflecting surface is curving inward. So here we have to locate the position of the focal point. Focal point, we have said for horizontal surface, the focal point is 10 centimeter, and for horizontal surface, 1 centimeter represent 5 centimeter. So here we have 1 centimeter will represent 5. Then if it's 10, the focal point will be here. 2 centimeters will represent now 10. So this is the focal point. Then another 2 centimeters from the focal point will represent the center of curvature. So in this case, the center of curvature will be at 20 since 2F is equals to R. So where we have C, we have 2R, that is 20. So here at C is 20. So in this case, we have to locate the position of the image that is being formed. We are told the image is formed 20 centimeters from the mirror. So in this case, if it is 20 centimeters from the mirror, then we will count. 1 centimeter represents 5 centimeters. So here 1 centimeter, this is 5, then this is 10, 15, 20. So the image was formed at the center of curvature. Then we have to draw that image, and then this image is its height is 5 centimeter. The image is 5 centimeter. Remember, when an image is formed in front of a mirror on a concave mirror, it is inverted, and it's 5 centimeter, and 1 centimeter on the graph represents 2.5. Therefore, if we have this one as our 1 centimeter here, 1 centimeter, no, 1 centimeter, and it represents 2.5. So here it will be 2.5. 2 centimeter will be here. So for us to draw 5 centimeters of vertical height, then we have to draw 2 centimeters. So in this case, 1 centimeter, 2.5. 2 centimeter will represent 5 centimeter. So here we will have to draw an image which is upside down like this one here, and it is 5 centimeter. In this case, from the graph, it is 2 centimeter. So after we have drawn that, then now we can construct 2 rays which can give us the characteristics or the position of the object. And here we can use the rays that we discussed. There is a ray that will be parallel to the principal axis. That ray was reflected or a ray from the tip of the object through point F was reflected parallel to the principal axis, and it formed the tip of this image. So in this case, for us to redraw that, there was a ray which was to the mirror parallel to the principal axis, which was reflected like this. And this image, this ray, it came from F. It came from F because it was reflected from the tip through F, and then it was reflected parallel to the principal axis. So now you will join this ray from that point to through F, and then like that. So that is the first ray that came for it to form that image there. So there was a ray which came through F. It was reflected parallel to the principal axis. Then another ray that we can use here is a ray that forms an angle with the pole or with the principal axis at the pole. This is the pole. Then that ray will follow the laws of reflection, where the angle of incidence will be equal to the angle of reflection. So from here we can draw a ray which is at an angle with the principal axis, like in this case, like let me use a different ink here. So we can draw a ray which is forming an angle. This ray formed an angle like that with the principal axis. Remember, it was coming to that point. Then this angle here, this is the angle of reflection. Then this angle of reflection was equal to the angle of incidence. So in this case, before it came, then you have to measure equal angle like this one here. In this case, it is 30 centimeter. This 30 centimeter should be equal to the 30 centimeter, which was the angle of incidence. So in this case, you have to draw 30. Yes, you measure using a protractor 30 degrees. Then this 30 degrees now will be constructed, or you join now them to the other end like this. So now, after joining like that, then this angle I was equal to that. Remember, the rays were coming in that direction. Then now where these two rays meet, that is the position of the object. So the object here was upright like this because the tip is up there. So now this is our object. Remember this object now, if we can draw now, we can draw a ray from the tip to the through F, it will be reflected parallel. We draw a ray which is at an angle with the principal axis, it will be reflected to following the laws of reflection. Now here where they meet, that was the origin of that tip. Then in this case now, that we have determined the position of the object, and that the position of the object is that the object was at C. So remember what we did in construction. When an object is at C, the image is formed at C. Then in this case, the height of the image is the same as the height of the object, but we can do that by measuring. You measure the height of this object. In this case, if I can measure, it is 2 centimeter. So HO, that is the height of the object, is 2 centimeter from the graph. But from the graph, 2 centimeter or 1 centimeter represent 2.5 centimeter. So if I have measured is 2 centimeter, then I will have to multiply with 2.5. So it is 2 times 2.5. Therefore, the object height is 5 centimeter. So through that, you have done a construction of that ray diagram. So the second question, an object of 3 centimeter high is placed 6 centimeter in front of a concave mirror of radius of curvature 10 centimeter. By scale drawing, determine the position of the image, the size of the image, and the nature of the image. What we do, we identify what we have. We have height of the image, that of the object, that is 3 centimeter. Then we have object the distance, that is 6 centimeter. Then we have the radius of curvature, which is 10 centimeter. Then if we have the radius of curvature, we can get our focal length, which if we divide r by 2, we'll get our focal length as 5 centimeter. So in this case, if we identify the scales that we have, the vertical scale lies under the image object height, and in this case, the maximum is 3. So 1 centimeter will represent 1.5 centimeter. Then now, for the other scale, that is horizontal scale, the maximum is 10, minimum is 5. 1 centimeter represents 5 centimeter. Then after this, we will draw a representation of this mirror on this graph. And what we do first, we draw a horizontal line which will represent the principal axis. Then we will draw a vertical line which will represent the mirror line. In this case, we will draw as tall as possible like that. In this case, this is our concave mirror. And now what we do, we identify the position of the focal or length, that is the focal point, F, it's at 1 centimeter. Then at 10 centimeter, we have the center of curvature. Then in this case, if we identify those two like that, then now we can place the object at 6 centimeter. So at 6 centimeter here, have an object of height 2 centimeter. So in this case, 2 centimeter on the graph, but 3 centimeter on the ground. In this case, we will have our object there, which is 2 centimeter according to the graph. Then after this, we will draw two rays, which we discussed earlier. A ray through, or which is parallel to the principal axis, will get reflected through F. So in this case, this ray will get reflected through F like this, like that. Then we have another ray, that is a ray from the tip of the object through C. It will get reflected along its own path. So in this case, we will draw a ray from the tip of the object. Then this ray is going to be reflected along its own path like this. Then it gets reflected along its own path like that. So in this case, this ray will go to the mirror and then it will get reflected along its own path. If I can trace it so that I change the color, but let it be like that. So those are the two rays that we can use. Now where these two rays meet, that is the position of the image that is being formed. So in this case, these two rays meet at this point here. They meet at this point here, and at this point where they meet, that is the image now which is formed. This is our image. Then now we can handle the first question, determine the position of the image which is formed. So they want us to find the distance of the image, that is V. So they want us to find V. In this case, our V will be, we measure the distance from the mirror to the object. Like in this case, this is 1 centimeter, 2 centimeter, 3 centimeter, 4 centimeter, 5 centimeter. So in this case, the distance of the object or of the image, this is the image from the mirror, is 5 centimeter. Is it 5? Let me measure accurately on my side here. That is it is 5 centimeter. So in this case, it will be, so 5 times, because now the distance from the mirror is 5, then now for us to get the real image distance, it will be times 1 centimeter represents 5 times 5, which is going to be 25 centimeter. So that is the position of the image from the mirror. Then now the size of the image, size of the image, if I can measure it here accurately, size of this image is going to be 8.2. So it is 8.2 times, remember the vertical axis is 1 centimeter represents 1.5. So times 1.5, which is going to give us 12.3. That is 8.2 times 1.5. That is 12.3 centimeter. Then now the nature of the image formed. The nature of the image formed here, we can describe it as the image is upside down, that is, it is inverted, or we can say inverted. Then the image is real because it's formed by convergence of real rays. Then this image is magnified. It's magnified, it means it's larger than the object. So you can now try this as an assignment. And that is the end of our lesson today. In the next lesson, we will discuss magnification.